You're staring at your network management system. The primary channel just failed, but the backup, well, it didn't kick in.
Yeah, and, your screens are just completely red.
Right. So, why did the protection switch fail? If you're prepping for the H31321 exam, the HCIP transmission certification, knowing the exact hardware or software mismatch isn't just theory.
No, it's literally the difference between passing and failing.
Exactly. Welcome to this Deep Dives, where our mission is a step-by-step analysis of 5 actual practice questions to uncover their core logic.
And just to ground you on the basics, you've got a 90-minute English test with 60 to 70 multiple format questions. You need a 600 out of 1,000 to pass.
Let's jump right in with basic prevention. Here is the full text of question 1. Which of the following operations are required for monthly maintenance of the U2000? Option A, check server time for synchronization. Option B, backup system files.
Both. Super important.
Definitely. Option C, update passwords. Or Option D, check OS logs.
So the exam really wants you to spot the odd one out here. Options A, B, and C, those are your correct preventative tasks.
Because they keep the system synced and secure, right?
Exactly. They ensure data safety and access security. But option D, the OS logs, is incorrect for a routine monthly list. I mean, operating systems generate like thousands of routine logs every day.
Digging through that is like looking for a needle in a haystack.
Yeah, or searching a city dump for a receipt you don't even need. You really only pull OS logs when you're reactively troubleshooting a specific fault.
Okay, so preventative software maintenance must be paired with physical hardware testing. Question 2 asks, when testing the 2 Mbit error rate on E1 interfaces, which of the following boards can a BER tester be connected to?
A very practical scenario.
Right. The options are Option A, D75S, Option B, D12S, Option C, 1SEP, or Option D, D34S.
So we're analyzing BER testing for E1 interfaces. The correct options are A and B. The D75S provides a 75 ohm port and the D12S provides a 120 ohm port.
Wait, why not C or D?
Because options C and D, the 1SEP and D34S, they completely lack 2ME1 interface support.
So you literally can't even plug the tester in.
Precisely. But the interesting thing is why we need both 75 and 120 ohm ports.
Yeah, doesn't having 2 standards just needlessly complicate the hardware?
Well, it does, but it's physically necessary based on your cabling. 75 ohm is for unbalanced coaxial cables, while 120 ohm is for balanced twisted pair. If you mismatch the impedance, the signal actually reflects back on itself.
Oh, wow. So you'd get false errors on the test.
Exactly.
That makes sense.
All right.
Moving to question 3. Once hardware is tested, we use the NMS to monitor our network safety nets. Question 3 asks, which of the following statements about querying protection switching status is false? Option A, the switching status of MSP can be queried on the main topology.
Pay attention to that one.
Yeah. Option B, SNCP switching status is queried in the NE Explorer. Option C, MSP switching status is queried in the NE Explorer. And option D, TPS switching status is queried in the NE Explorer.
This one is tricky because it's asking for the false statement.
Right, but shouldn't the global main topology view give us everything we need?
You would think so, but no. Option A is the correct answer because it is the false statement. Main topology only gives you the physical links.
It doesn't show the granular switching status.
No, pulling that granular state across a whole network would just overwhelm the system. So B, C, and D describe true procedures. You must use the NE Explorer to check specific protocols like MSP, SNCP, and TPS.
Got it. Okay, question 4 brings us to our opening scenario. What happens when monitoring shows a protection switch was triggered but failed to execute? Question 4 asks, what are the possible causes for a protection switching failure? Option A, faulty cross-connect board. Option B, faulty line board or tributary board.
The usual hardware suspects.
Right. Option C, inconsistent data between the NMS and NE. Option D, equipment power failure. Option E, faulty SEC board.
Okay, so options A, B, C, and D are your correct causes here.
Let me guess, A, B, and D are just physical hardware stops.
Exactly. A faulty cross-connect, a bad line board, or a dead power supply. Those just physically block the switch from executing.
And option C is interesting, inconsistent data.
Right. If the NMS and the local network element have conflicting configuration data, the local element won't trust the command, so the switch fails.
What about E, the SCC board?
That's incorrect in this context. It manages system communication, but isn't the direct cause of a localized service switching failure here.
Okay, final question. That data inconsistency from question 4 often traces back to embedded control channels, or ECC. Question 5 asks, which of the following statements about ECC routing are correct? Option A, ECC routes are based on physical geographical distance. Option B, the route is selected at the transmit station.
Keep track of that transmit part.
Yep. Option C, ECC automatically guarantees the shortest physical path. Option D, routes are established based on the lowest M and E address. Option E, distance is measured in logical hops.
For this one, you need to evaluate basic ECC principles. Options B and E are correct.
So the route is selected in the transmit station, and the distance is logical hops.
Yes. Options A, C, and D are incorrect because ECC isn't based on physical geography, and it certainly doesn't guarantee the shortest physical path.
It's kind of like passing a note in class, right? The person could be 2 feet away from you physically.
Yeah, but if there's an aisle, the note has to go down your row, across the back, and up the next row.
Right, so it might be 5 logical hops for a 2-foot physical distance.
Exactly. The network route's based on logical topology, not physical proximity.
Mastering these technical concepts, from physical impedance to logical routing, is really how you pass the H31321 exam.
It really is. You have to understand the underlying logic of these systems.
Absolutely. But here's a provocative thought to leave you with. As these transmission networks increasingly rely on AI and automated self-healing, how much longer will manual, hop-based, logical routing protocols like ECC even remain relevant?
That is a great question. Will they have to fundamentally evolve?
Something for you to think about. Good luck with your prep, and keep questioning the system.